Welcome to a lesson with Dr. Powell. Let's take a look at computing the determinant of this matrix, and we're going to use sliding or airdropping. That is, if we airdrop on this matrix, it won't change what the determinant is. The determinant is a number associated with this matrix. It could be thought of as an oriented three-dimensional volume here, since this is a 3 by 3 square matrix. Our goal is to airdrop in such a way that we get a matrix with zeros off this diagonal. And so the only non-zero entries will be on this diagonal. And then what we do is we take the product of these. So we can actually define a determinant of a square matrix as being the product of this diagonal if there are zeros everywhere else. Okay. And then if we want to find, and then knowing that that sliding does not change the determinant, we can use sliding to change any matrix into this form, then just compute the determinant by multiplying these guys right here. Sliding being airdropping. Essentially what we're doing is, if we think of these vectors as columns right here, or these columns as vectors, you could plot these, and it frames out a parallelogram space. Then really what you're doing is you're just finding you're computing the volume of this. But airdropping, essentially what it does is it just takes this and it straightens it out so that your vectors, like one in the x direction, y direction, z direction only, and so it just becomes a rectangle or a box. And so computing the volume just simply is multiplying the lengths of these, which would be like multiplying the values down the diagonal. So that's how we're going to compute the determinant in this example. All right, just kind of getting set up. That's what we're aiming for. So let's do it. So let's turn this into a matrix, which only has non-zero entries on the diagonal. So we can airdrop, we can use row or columns. That's fine. We don't want to ever rescale a row or a column, because that would change that oriented volume. It would change the determinant. Like lengthening one side by a certain amount actually does change the volume. Okay, so let's take a look at this, and we have let's do some airdropping this way. Let's see. We want to get a column, right? We want this to be like this. We want to get these to be non-zero, right? So maybe, airdrop off the diagonal this way or that way, maybe perhaps something like that would be fine. Okay, so let's try that. So we take this and let's airdrop this way. So let's multiply by a negative a half. So if we multiply this -2 by negative a half, we get +1 added to that would give us a 0 over there. And so over here we have a -1 times a negative a half would be a positive a half, plus the -1 would be a negative a half. And then you have -2 times negative a half would be a +1, and adding over would just be 1. So essentially everything else has stayed the same so far. Okay, we get something like this. Now this is really nice, since we have a -2, 0, 0, so that if we airdrop down this way, it doesn't really matter what happens down these columns, because this is 0 here, and as we take a multiple of it and add it down, it's not going to change things. Okay, so right here, essentially, we don't even have to concentrate on what happens. We could just clear this out and just say -2, 0, 0, 0, 0, 1, negative a half, 2, and 1. Okay, now let's see. Let's airdrop maybe this way right here. maybe multiply, okay, so right here, maybe multiply the 1 by a half, and add over to make that a 0 over there. So this would be a 0 there. And the 2 times a half is a 1. Added to that 1 would be a 2. Okay, so 0, 0. So that would be a 2 there. And then we have 0, 1, 2, -2, 0, 0, just like that. Now, from here, we can airdrop just down this way. Notice that it doesn't really matter what we do here because 0 times anything won't, and 0 won't affect anything. So, but we know that we can, and so that gets rid of that. So we're left with -2, 0, 0, 0, 1, 0, and 0, 0, 2. Notice that the product, these diagonals, is -4, and that is the determinant of this matrix. We found it simply just by airdropping. Thanks for watching.